Let's look at this A-level mathematics question. Evaluate the integral of 1 all over 1 plus sine x dx. Very simple and easy. Looking at this question here, you see that look at the denominator here. It's a different expression. We have 1, we have sine x, and we have a sine in between. So we have to make it a whole, expression. So we think of the conjugate of this 1 plus sine x. And don't forget, the conjugate of this plus is minus. So just use 1 minus sine x to multiply this numerator and denominator while you write the expression first. So let's do that now. Now what we have here will be 1 all over 1 plus sine x. You can say that the conjugate of 1 plus sine x is 1 minus sine x. So use that to multiply 1 minus sine x at the numerator and also at the denominator. Hope you understand. So let's multiply. 1 times this is still the same thing. It's 1 minus sine x, all over. Now, this times this, don't forget, since we have conjugate, we have plus here, we have minus here. Just use the first one times first one, then second one times second one. You don't need to expand this one by one. So just say 1 times 1 is 1. That's for the first one. Then last one here, plus times minus is minus. Sine x times sine x is sine square x. Sine square x. You understand me now? So this whole expression becomes this now. You understand me now? So we're going to have 1 minus sine x all over. Now don't forget from trigonometric identity, we know that sine square x plus cos square x must give us 1. You understand me now? So look at this 1 minus sine square x here. So that means my cos square x will be 1 minus sine square x. That means 1 minus sine square x becomes cos square x. You understand me now? So and that's what I'm going to put here now. My 1 minus sine square x becomes cos square x. Excuse me. You understand me now? Now look at what we have here now. In mathematics, if you have something like this, let's say you have 9 plus 6 plus 3 all over 3. We can say, okay, 9 all over 3, 6 all over 3, 3 all over. We can give them the 3 one by one and still get the same result. So that's what we are going to do here. You understand me now? So we just say, okay, this one, we take its own cos square x. You understand me now? Then minus the sine x also takes its own cos square x. You can see now. So we are giving them one by one. Now, don't forget that. Don't forget that 1 all over cos. Excuse me. Don't forget that 1 all over cos is always sec, which means 1 over cos square will now be sec square x. You understand now? So that's going to give you sec square x. You see now? Minus. Now, how do we do this? This one means this cos square x means cos x times cos x. So we can say sine x all over, this is cos x times cos x. So we have cos x times cos x. So we have, this sine over cos is tan. Don't forget, in trigonometry, sine all over cos is tan. There's a 1 here. 1 over cos is what? Is sec. So times sec x. You can see now. That means this whole expression means tan x sec x. And that's what I'm going to put here now. Here. So we have tan x sec x. Understood? So we have tan x sec x, or I can say sec x tan x from commutative law of multiplication. So we have sec x tan. So this whole expression has become this. dx. Your integral. You can see now. So this has become this. Now, how do we integrate this? Don't forget from standard integrals. From standard integrals, don't forget, if you differentiate tan x, you will get sec square x. Differentiation and integration are inverse. So which means if you now integrate sec square, then you get tan again. So if you integrate this sec x, you get tan x. Tan x. Don't forget plus a constant. Now minus. Now if you also integrate, if you differentiate sec x, you get sec x tan x. Now if you now integrate sec x tan x, you get to sec x again. Sec x again. Don't forget that the constant that we have here, with the constant here also we'll have, either add each other or subtract and turn to a single constant. So let me call that single constant plus c. You can understand now. So that means the integral of this expression, which gives us this, will give us this. So this is the final answer. Tan x minus sec x plus the constant c. You can see very easy and simple. Once again, welcome to Mr. Bam's online class. Don't forget to like my video, drop your positive comments, and follow me. Thank you.